Hi everyone, my name is Ashiff Khan. I presented halfway of what I did on this topic last year, and this is my second presentation in this conference. So the topic is about antecedents of adoption of big data by global oil and gas industry, or specifically chemical industry. So this was done with myself, with the Dr. Sita Raman, as well as Dr. Abhijit Dasgupta of SP Jain School of Global Management. So in this, I will take you through 5 steps, which is the introduction of the topic, literature review, research methodology, data collection and analysis, followed by results and conclusions. To start with topic, why we selected chemical industry is that chemical process, as you know, it involves several variables. Any problem in chemical industry is usually a multivariate problem. And this is one of the industry which used computer-based control system for decades and is known as a pioneer when it comes to usage of computer-based control system in industries. A lot of operational data, maintenance data, and financial data, they are generated in chemical industries. And this is one of the industry which has quite a lot of experience in using data or big data. And why big data, which is the second variable chosen, is there are several research gaps found in prior literature, and very less focus is given in prediction and forecasting in chemical industry, even though they process quite a lot of data. And it is expected that with the use of this data in a nice way, we can improve the QHSE and chemical industries. And most importantly, to shift from the conventional decision making to a data-driven decision making in chemical industries, and to tap into the opportunity of transformation to smart industries. As a research problem, this is a relational research which focuses on adoption of big data by global chemical industries. The research problems are derived from critical research gaps highlighted in relevant articles as scope of future research. 5 significant gaps were identified part of the literature survey, which are considered as a research problem for this topic. Moving on to my second part, which is the literature survey. As part of this research, extensive research literature review was conducted. More than 500 to 800 articles were actually reviewed to identify the gap, the research gap. These critical research gaps were extracted from the future scope of research, and they were actually tallied to find the most important gaps that needs to be adopted by the chemical industry. So based on the gaps identified, the dependent variable for this research is identified as antecedents of adoption of big data by global oil and gas industry. The critical research gaps were professional competencies, business intelligence, data scalability, process monitoring, and investment in tools. The sub-variables part of this research framework for each of these identified independent variable were also conducted part of this research. So approximately around 500 to 800 research literatures were scanned to develop this research framework. As a measure of the dependent variable, we identified some variables based on literature survey, which includes critical thinking, competitive advantage, faster data processing, forecasting resources, and smart decisions. The research questions were like that, how the professional competencies of employees are influencing big data adoption in global chemical industries. And the research objective was to determine the influence of professional competencies in global chemical industries for the preparation of and implementation of big data. Similarly, for each of the identified variable, which is for business intelligence, data scalability, process monitoring. Process monitoring is nothing but fault diagnosis, optimization, and prediction in chemical industries, and investment in tools. For each of these research questions were developed, and accordingly, the research objectives were also developed part of this research. In terms of research hypothesis, the first, I will only explain the first one, which is related to the professional competencies. The null hypothesis was professional competencies significantly influences the adoption of big data in global chemical industries through its sub-variable identified part of literature survey, which is demand for skill and expertise, management commitment, organization readiness, training programs, and job demand. So similarly, the null hypothesis were developed for business intelligence, data scalability, process monitoring, and the last identified independent variable, which is investment in tools. And in each of these, the sub-variables were also broad part of the null hypothesis. Moving on to the research methodology, moving on to the research methodology, this research adopted a positivist philosophy. A hypothetical deductive approach was utilized. A quantitative methodological choice was quantitative. The strategy was survey-based approach, and the time horizon was cross-sectional. As part of this research, data collection and analysis were done using questionnaire. A snowball method of sampling was adopted. Structural equation modeling was developed using Adanko software. Also part of this research, ethical considerations were met. Research integrity and merit, informed consent, risk management, privacy and confidentiality, and ethics approval from concerned authorities were secured part of this research. Now, moving on to the most important part, with this data collection and analysis. As part of this data collection, Google Forms were survey sent to multiple respondents who are mainly working in chemical industry. The respondents profile is as like this. Majority of the people, like around 70%, had bachelor's degree and 22% had master's degree. A few people, respondents, they had even doctorates. Now, in terms of location, a fairly good distribution in Asia, Middle East, Europe, North and South America, Africa, and other regions were secured. So, which means this research was being presented as a global kind of thing for chemical industry. Most of the people, as you can see, around 95% of the people were actually working in chemical industry who were participated in the survey. And also a fair distribution of male and female was also secured in this survey. Now, in terms of the most important part, which is the analysis, the first one part of this was developed based on a Adanko structural equation model. In terms of the construct reliability, this is nothing but a measure of internal consistency to check whether the constructs belongs to the same group or not. As you can see, all the three parameters, be it Heinzler or Joresberg or Kornbeck alpha, they are very close to the value of 0.8 and above, indicating all the constructs showed internal consistency. In terms of convergent validity, which is nothing but whether to check whether the constructs are distinctly different or not, the average variance extracted is crosses the threshold value of 0.5, which indicates each of these constructs are distinctly different, even though they show the same internal consistency. In terms of discriminant validity, if you can see the diagonal, which is maximum in the whole rows and column, which is above 0.5. So it also indicates that each of the constructs, they are distinctly different and they can be adopted for further analysis. In terms of loadings, you can see that each of the indicators, just let me try to move this. In terms of loading, each of the indicators were loaded heavily on its construct. As you can see, the numbers were like 0.7. This is nothing but a correlation coefficient. There were a few values like the subvariable number 5, which was less than 0.7, which is the threshold of correlation, and also the investment in tools, which is IT1 subvariable, was like 0.54. But still we continued using this subvariable because as a group they showed the internal consistency, as I explained, and the constructs were proven as distinctly different by the validity measurements. In terms of the cross loadings, you can clearly see that each of the indicator, which is the subvariable, is heavily loaded on its construct as compared to the other construct. So all the constructs, all the indicators, you can see they are loaded on their constructs and not on any other construct. So the cross loadings were also passed. In terms of multicollinearity, the threshold is 5, as you know, and as you can see, the multicollinearity value is very less, indicating all these indicators and construct. There is no multicollinearity issues exist. So finally, the structural equation model, as part of the structural equation model developed by Adanko, the R square value the 50 is 54.1%, which indicates that the 54.1% of the model is already explained by the model itself. Going back to the results and conclusion, in terms of data analysis, as you can see, the beta coefficient for the first independent variable is positive, which indicates that increasing in professional competencies increases adoption of big data by chemical industries. However, the t-value, which is actually less than 1.65, so this indicates the beta coefficient is positive, but the t-value is not really good. So it indicates this is not significant. That is the influence of professional competencies on big data adoption, even though it's positively influencing, but it is not really significant. These findings were also verified from other literatures, which indicate that professional competencies alone cannot increase the adoption of increase the influence of technology adoption, because there are other things like experience of the professional or age of the professional, willingness of professionals to learn. They also affect the influence of technology adoption in the organization. The second one is business intelligence. It also showed positive beta coefficient, indicating that increasing in business intelligence can increase big data adoption in chemical industry. However, the influence is found to be moderate, because the people who use business intelligence, they did not have too much knowledge about big data or AI related softwares or things like that. The other three coefficient, which is data scalability, process monitoring, and investment in tools, as you can see, the beta coefficient is positive, and the t-value is very high, about 2.5, which shows that there is a very significant influence of all these three variables towards the big data adoption in chemical industries. And this is the key contribution of this research towards industry and practice. As part of the model, several indirect effects were also studied. I'll just go ahead and explain one of the indirect effect. Indirect effect means whether there is a mediating effect or not. So if I just take the first one, as you can see, the professional competencies influences process monitoring through business intelligence. So this is one of the indirect effect. And we found that the coefficient is positive and t-value is very significant, indicating there is a partial mediation. Another one, like professional competencies about the big data, it was not supported. For professional competencies for big data adoption mediated through process monitoring, it is a beta coefficient is positive, t-value is 2.77. That means process monitoring can influence professional competencies for big data adoption. Even though we found that the direct influence of professional competencies in big data adoption was not there due to several factors that I explained in my previous slide, the mediating effect of process monitoring can increase the influence of professional competencies on big data adoption. Similarly, there were around 11 indirect relations part of the Adanko were studied part of this research, and the mediating effect of all these indirect effects were studied and furnished part of the research. Now, moving on to the theoretical contribution, this research tried to study this whole thing using UTAUT, Unified Theory of Acceptance and Use of Technology model by Venkatesh in 2003. So this is the model that used by Venkatesh in 2003. In 2012, there is an additional model that was developed by Venkatesh with 3 additional variables, which was mainly related to consumer market. So the model that is being presented here is 2003 version. Why we used UTAUT model? There are several other technology adoption model, but this is considered as a unified model which integrated several other model. This model also aimed in providing a holistic insight into all the factors which have influence on behavioral intention towards new technology. There are some criticism about UTAUT model because this is very complex model, because there are several constructs in the model. These moderators, gender, age, experience, and volunteer, they make the model, the explanatory power of the model goes very high with these moderators. However, they increase the complexity as well. It is found that many researchers try to ignore these moderators when they use this model. So what we found part of our study is that the gender, age, and experience, which we collected data in the survey, they did not really influence the technology adoption, especially if the technology is at early stages. So these moderators are more effective only if the technology is in advanced late stages or mature and higher levels of maturity. These moderators increases the explanatory power of the model itself, but at the early or infancy stages, these moderators are not really required in this model, and they can be ignored. So this is one of the contribution that we did part of this research. Now, in terms of theoretical contribution towards industry, this is the analytical maturity model using Davenport and Harris. So we try to place chemical industry in this model, in this analytical maturity model. As you can see, in the stage 1, this means the data is poorly organized in the industry. Stage 2 means data is usable but in silos. Stage 3 means organization started beginning using the data. Stage 4 and stage 5 are much more matured level. As I explained in the stage 1 in chemical industry, because this is one of the industry which use data for quite a long time, even decades. So for chemical industry as a global picture, we can say that the chemical industry is already crossed big data stage 1, because it is very familiar with using the data. So the starting point of chemical industry in terms of analytical maturity is at stage 2. So based on that and the literature survey and the data collected and the results presented, we place the global chemical industries in stage 2 and stage 3. This is where the chemical industry stands. And there is still a lot of way to go towards analytical maturity and to get big value from the big data which it owns. This picture of chemical industry is actually a global picture. However, we also understand that this is not the real picture when it comes to MSME organizations. Because in MSME organization, the data does not exist actually. So they may be in the stage 1, but as an overall picture, when we compare into the major industries like oil and gas or mining and metal and things like that, we place chemical industries in stage 2 and 3 when it comes to big data adoption. In terms of limitation and future research direction from this research, we presented only 5 independent variables, which is professional competencies, business intelligence, data scalability, process monitoring, and investment in tools. However, part of the 500 to 800 research articles that were reviewed, there are other key variables which needs to be studied in the future, which includes data privacy, cybersecurity, data quality, MSMEs, external factors, etc. And Adanco, it's a linear model. So there are some key variables like professional competencies and business intelligence. The linear relationship was not very strong. However, non-linear relationship can exist in this kind of this independent variable. So as a future research gap, we suggest that a non-linear relationship between the identified independent variables can be studied. The research actually presents a global picture, but a industry-specific or region-specific research is also recommended. And also, as I mentioned, the big data adoption in MSMEs is one of the key factors that can be studied in the future. Now, in terms of conclusion, the research meets its objective to recognize the influence of identified independent variables with dependent variable, which is the research problem and research objective that was presented at the beginning of this research. This contributes to the limited available research of big data and AI in chemical industries. This research contributes to both theoretical and industrial applications of big data in chemical industry. It guides chemical industry to shift from conventional decision making to data-driven decision making, and contributes for the transformation of chemical industries to smart industries. That's all from my side. So this is my email ID and LinkedIn. If there's any question, feel free to ask, or you can also connect to my LinkedIn and post any questions if required. That's all from my side, and thank you very much.